Recording in progress.
Okay, there's chapter 10, it's called the first sections. Let's have a continuation to chapter 1. Lines, we know lines. Inclination of a line. So lines, let me do it here. If you have the coordinate system, line is going to make an angle, we're going to call it theta, with the x-axis. Always we talked about this angle with the x-axis. So this is the acute angle. Then if it, when the line go down, this is the angle. This is the theta. If theta equals 0, then the line is horizontal. You can see here theta 0. And also if it's vertical, then theta is pi over 2 or 90 degrees. So this is right angle for the vertical line. So theta acute angle, obtuse angle if it is greater than 90. Less than 90, acute. More than 90, obtuse. One thing important, that tangent theta is the slope of the line. Remember, we studied the slope. If we have 2 points, and we said m is equal y2 minus y1 over x2 minus x1. However, this angle here, theta, this is m. M equal tangent theta. So if I know the angle, I would know the slope. I don't need x and y whatsoever. But if I don't know the angle, and I ask you what is the angle is going to be theta equal tangent inverse of m. What's the meaning of tangent? That reverse. Tangent theta will give you m. But if I have m, then I say I find the angle, tangent inverse of m. It said find the inclinations of those two lines. If I know m, then I know the theta, right? All what I need to find m. The first example, x minus y equal 2. I need to reorganize it such way. See, the general form, y equal mx plus b. So I need to write this equation in that form. If I take the y to the other side and so move the y and become positive y, and move the 2 to this side, become negative 2. Then you get y equal x minus 2. If you want to orient yourself, you can say y equal x minus 2. But it doesn't matter. So what is m here? M is equal 1. Now what the angle? Theta equal tangent inverse of 1. If you have a calculator, do you have a calculator? Type 1 in your calculator, and you must have a shift key, and push the shift key and push the tangent. Should give you the angle. .785. This in radian, what you got, that's not in degree. Does it, do you have a button that said convert to degree? Yeah, well, also you have, there is a default, you need to learn that in your calculator. Tell you either use degree or using radian. You should find out where you change that default about degree and radian. So, well, let's see. So we're gonna use both of them in the future. You need to know how to switch back and forth between degree. However, we can convert, we'll learn how to convert it later on to degree. It said here that, see, arctangent is the same as tangent inverse, but this different symbol, that's the same. Arctangent means the same thing. So what we did, tangent inverse of 1, they got the answer pi over 4 was, I think that's basically 3.14, 1 over 4. That should be 0.87, the number he gave me. That's correct? So that's the same number, 0.785 radian. Well, pi over 4, I know how much is pi over 4. Pi over 4, pi is 180. Pi equal 180 degree. So if I divide 180 by 4, it's going to be 45 degree. Okay. They converted here to degree. So here they said it's 45 degree, but they didn't tell you how. They're assuming you know how to do it. Or some calculators, they have conversion. If not, we will learn how to do the conversion. But this is easy because pi equal 180. We divided by 4, we got the answer. The other problem that two x plus 3y equals 6. The same thing, because y is positive, I'll leave it on this side, equal, take the 2x to the other side, become negative 2x. So we get negative 2x plus 6. Divide by 3 everywhere. Y equal negative 2 over 3x plus 2. So m, how much is m? Negative 2 over 3. Now, if you do the theta, it is tangent inverse of negative 2 over 3. Okay. All right. I'll explain to you what that means. Still, we need, it's very hard to imagine a radian. I wish you can, maybe it's better to convert to what they, okay, if I have, this is X, this is Y. If you go this way, this is positive angle, positive theta. If they said negative, you're going that way. That's negative theta. Okay, that's going down. I mean, to know what is this angle really, you have to take 0.5888 multiplied by 180 divided by 3.141. That will give it to you in degree. Okay. I don't know. Did you do how much? How many? They will tell me how many degree in here, I think. Okay. Okay. So basically, if I said here, the angle, I'm not sure, this angle here, they calculated the complementary one. So what you calculated, 180 minus 146. So that's basically about 34 degree. That's what you got, 34 degree? Okay. That's 34 in the negative side. Okay, angle between two lines. All right, if I have two lines, first line making angle theta 1 and the other one making angle theta 2. The angle between those two lines, theta, is equal the larger one minus the smaller one. So theta equal theta 2 minus theta 1. So or angle 2 minus angle 1 equal to angle between. So this is between lines. Okay. If I take the tangent of both sides, let me go back in here. If I take the tangent of both sides, I say tangent of theta, that should be tangent of theta 2 minus theta 1. Well, there is a formula in the reference book. You don't need to worry about it. And it's just we're gonna accept it that tangent theta 2 minus theta 1 will be equal to this formula. Tangent theta 2 minus tangent theta 1, and in the bottom one plus tangent theta 1 multiplied by tangent theta 2. However, what did we say about tangent theta? Tangent theta, we said equal to m. So we're going to convert everything to m. So I'm going to leave this tangent theta because this is unknown yet. Tangent theta equal to m2 minus m1 over 1 plus m1 m2. And oh, the bar, oh, so low. Okay, so However, because I don't know which one M2, which one is M1, we are going to do this in absolute. So there is no negative answer. Okay, no negative answer. No negative. It's going to be one angle. Then theta is going to be tangent inverse of whatever value I got. Here's the formula. Well, they didn't tell you like you do theta tangent inverse. Theta is tangent inverse whatever you have. Now find the angle between two lines. They give me first and second. We have to convert them to the convert to form y equal mx plus b. So 2x minus y equal 4. That's lead to y equal 2x minus 4, like we did before. This one here, the other one, we have 3x plus 4y equal 12. We're going to say 4y equal negative 3x plus 12. Because we'll move the 3x to the other side, become negative. Now divide by 4, both sides, you get negative 3 over 4x plus 12 over 4. Okay, divide by 4. By 4. Now, let's see. If I look at this equation here, M1 equal 2. M2 equal negative 3 over 4. Also, you can name any one you want it, M1 or M2. It's not going to make a difference in the answer because we're taking absolute. However, the first one is M1, the second one is M2. Now, what is tangent theta equal to? Tangent theta equal to the formula absolute M2 minus M1 over 1 plus M1, M2. Let's plug in. M2 is negative 3 over 4. M1 is 2, negative 2. Over 1 plus M1 is 2 multiplied by negative 3 over 4. It's all a bunch of numbers. Now, if I look at this, I can write this one 8 over 2. That's going to be negative 11 over 4. So from here to here, negative 11. All what I did made the bottom, I multiplied top and bottom by 4, become 8 over 4. 8 and 3 is 11. Now here 3, 2 multiply by 3 is negative 6 divided by 4. Oh, I'm going to get 1 minus 6 over 4. Well, 6/4 basically is 3/4. So this thing is equal negative 11/4 over, if this is 1 minus 3/4, what's the answer? 1 minus 3/4, we're going to get 1/4. So this is going to be 11. Now theta should be tangent inverse of 11. No, I think I made a mistake. No, I did not make a mistake. Yes, I did. That should be 2, because if this is 2, then make this 2/2 is going to be half. Negative half. So basically what you're going to have 11/2. Yeah, if you use calculator, you shouldn't have no issue. I'm trying to do it in my head. Now you can use your calculator and find the angle. Let's see what they did. Yeah, 11/2. That's exactly what we got. Now theta is arctangent or tangent inverse, the same thing in your calculator. It got 1.39 radian. They converted is 79 degrees. So the angle between those two lines, 79.7 degrees. So really the question is easy. You have this formula in your formula sheet. First you find M1 and M2, plug in, you find the angle. That's it, straightforward. Find the angle between those two lines. You know, it's always to convert to degree. I mean, let me show you how you do this. Pi equal 180, right? If I have the answer in radian, I put it over here, 1.3909. What I don't know in degree is x. Then what is x? You multiply those numbers, divide by this. So x equal 180 times 1.3909 divided by pi. Pi is 314. Normally you should have a button in your calculator said pi. You can just push it or 3.1. If you cannot find it, just 3.141. That's the value of pi. Then that should be give you the answer 79.7 degrees. So that's the easiest way to convert, make a balance. Pi equal 180. What is given to me is radian because pi is, this is the radian. Then x, that's what I'm looking for. So x what equal? Multiply, divide. I'm trying to show here like an asterisk. The distance between a point and a line. So basically, if I have a line in space and I have a point, we're looking for the normal distance. How far? This is D question mark. That's what we're looking for. Distance between a point. Let's call this is x1, y1. And we have the y equal mx plus b. How do you find that distance? Let's see how. And if you see here, like they said, we can also find the intercept point between, we can find the point where it's touching. All right, the process like this, no matter, convert. The first thing you do, convert line equation to be in this form. This one. If it's like y equal, you have x plus b plus c equals 0. After you write it in that form, you plug into this equation to find the distance value. What is the distance? Is equal to a, which is we can multiply by x1 for this point, the given point, plus b multiplied by the y, the given point, plus c, divided by square root of a squared plus b squared. So the top is also absolute because we don't know how to, the equation could be written multiple ways. So we need to make the top absolute. All of this in your formula sheet. I think I don't know if I give you one or not. Do you have a formula sheet? Example, find the distance from this point to this line. First, we have to convert you can do it two ways. Either you take the 2x plus 1 to the other side or take the y to this side. It doesn't matter. So you can say 2x minus y plus 1 equals 0. Or you can say 2x negative 2x negative plus y negative 1 equals 0. So either move to this side or that side, both of this, okay, or, okay? These are the same equation because they are equal to 0. Now, if I take the first one, first number, A equal 2, B equal negative 1, C is equal 1. So first identify A, B, C. Then you say, the distance D equal. The method said A x1 plus B y1 plus C. Absolute. Divided by square root A squared plus B squared. That's equal. Let's see what the data we have. A we said is 2. Multiply by x1. This is here x1 y1, that's given to me, x1, y1. Then I have to say here, x1, what is the x1 value is 4. Plus, or I see negative in the formula. Negative, because, so B is negative 1, multiply by y1, which is 1, then plus 1, the value of c. Divided square root of a. How much is a? We said 2. So we have 2 square plus b square negative 1 square. Let's see what's the answer. 8, we have 1 minus 1 is gone. We're going to get 8. Well, absolute 8 is 8. Then we have here 4 plus 1. It's going to be square root of 5. That is the distance. You can use your calculator to find the answer. 8 divided by square root of 5. And if I use the other one, all these signs will be flipped. So then it doesn't matter because I'm using absolute. That is the distance. Okay, the answer was 3.58 units. And here they give us the drawing. This is the given line, we plotted it, and here's the given point. The distance is going to be making 90 degrees. That's the distance. That's what we find out. This is a 3.58. That is the distance from here to here. Okay. Let me ask you, how do I find the equation of that distance? What's the equation of this line? I have a point is given to me, is passing through that point. What is missing I need to find the equation of a line? Another point, that's one option. What's the other option? Because I don't have another point. The other option is the slope. If we have a slope and a point, you can find the equation of the line because y minus y1 equal mx minus x1. Well, we know 4, 1, this is the x1 and y1. We have them. The only thing is missing the m. At the end of in chapter 2, we learn how to find the m for that line. This line, remember finding equation line passing through a point and perpendicular. What was the m for perpendicular? The inverse 1 over m. All right. What is m for that line what we're working with? It said 2x. So m is equal to, right? So the perpendicular is negative 1 over 2. We find the m. Now let's plug in to find the equation. Y minus y1, which is 1, equal negative half multiplied by x minus 4. Then y equal negative half x plus 4 over 2 plus 1 by moving the 1 to the other side. Y equal negative half of x. Now 4 over 2 is 2, 2 plus 1 is 3. This is perpendicular line. Perpendicular. Perpendicular line. Okay. So the original equation was y equal 2x plus 1. Can we find this point? What's the coordinate of this point? How do I find this point? Okay, just a minute. What coordinate of this point? Where is this perpendicular line intersect with the line? So how do I find this coordinate? X and Y value, how do I find them? Let's see. You don't know yet. I mean, don't worry about it now. That could be question in the final. Because in chapter 7, we'll learn how to find it. We are not there yet. Basically, there is a way to find the intercept point between two lines and solving the system together. So we are not going to worry about that point now. We may come back to this problem later on when we learn in chapter 7, solving system of equations. Okay. But we know how to find the equation because all what we need is the slope and plug in. Okay, so that's all what I need from chapter 10, basically finding an angle between two lines and finding the distance from a point to a line and the equation of that line. Okay, we have a practice here. Okay, let me use my mouse. The question is, we have two equation over lines and find the angle between those two lines, then find normal distance from this given point to the first line. And then find the equation of this normal distance. That's exactly what we did in class. Find the angle between two lines, find the normal distance, then find the equation of that distance. You copy them, those two lines. Go ahead and do some practice. Okay, I made this problem to be submitted by tomorrow evening. So I give a chance for the other guys. Okay, on Thursday we'll have a test on chapter 1. I think I mentioned section 6, 7, 8, and 9, and section 1 in chapter 10.